Okay, let's dive right into this explainer. Today, we're going to completely change how you look at a contract. If you're a highly logical thinker, but programming syntax kind of feels like an entirely foreign language, well, you are exactly in the right place. We are going to bridge the gap between traditional legal drafting and core computer science principles, shifting your whole mindset from static paper to dynamic execution.
Here is our roadmap for today's explainer. We'll start with the calculus of law, move into instructions versus legal data, map out strings and numbers, tackle assignment versus equality, break down Boolean logic and conditionals, and wrap up with the future of law.
Starting with Section 1, the calculus of law, shifting paradigms.
So think about this for a second. It's a foundational question for law students and traditional lawyers. What is the actual difference between a standard contract and a software program? To figure that out, we have to look at how these documents behave out in the wild.
Imagine a single data entry just sitting there in a Google Sheet. It's completely static, right? It just exists. Now compare that to a script written in JavaScript. In the code, that exact same data is suddenly alive. It's actively executing a task. This is the paradigm shift we need to make. We are moving away from a dead piece of paper and stepping into a dynamic, active environment.
In the software world, the execution of programmed instructions is called a runtime. In the legal world, fulfilling contractual obligations is called performance. And conceptually, they are completely identical. Think of it like a stage performance. You're the composer, writing all the verses and choruses beforehand, and the runtime is what actually happens when you finally hit play and the music starts.
Moving right along to Section 2, Instructions versus Legal Data, Decoupling Logic from Material.
This is honestly mind-blowing, but our digital world was essentially architected by translating traditional legal engineering. Charles Goldfarb, often called the grandfather of the internet, actually invented markup languages based on digitizing traditional legal redlines. And later on, Nick Szabo architected the very first smart contracts by literally hard-coding the legal requirement of consideration straight into the code. Computer science and legal drafting absolutely share the exact same DNA.
Because of this shared history, we can confidently start to decouple the actual rules of a contract from the raw data that the contract evaluates. You have the machinery, which are the instructions of the logic of execution, and you have the material being processed, which is the data itself. To write effective computational law, you have to know exactly how to handle that raw material.
Let's get into Section 3, mapping strings and numbers, the core translation.
All right, pay close attention here because this matrix is absolutely crucial. This is how we map basic programming data type primitives to their conceptual equivalents in legal drafting. If you want to read code like a lawyer, you just need to translate these three basics. First up, strings. In programming, a string is just text. In a contract clause, strings handle the entity names and addresses. They literally cast the actors in our play. Next, numbers. As you'd expect, these govern the financial values, the deadlines, the money. Finally, Booleans. A Boolean is simply a true or false value. In a contract, Booleans are your conditional triggers. Has the buyer paid the invoice? It's either true or it's false. By strictly mapping these out, the code prevents massive, costly execution errors before they ever even happen.
Which brings us to Section 4, Assignment versus Equality, Overcoming the Grammar Hurdle.
Before we can hit play on our runtime, we have to clear a major grammatical hurdle. To overcome our natural English prose biases, we have to adopt a right-to-left reading technique. You see, in code, a single equal sign assigns a value. You are declaring a fact. Let the buyer equal John. But a double equal sign, that actually investigates a condition. It asks a question. Is the string provided strictly identical to John? It is the critical, fundamental difference between assigning a value and checking for legal equality.
Let's see how that builds into Section 5, Boolean logic and conditionals, resolving the and/or trap.
So in traditional legal prose, the notorious and/or clause uses vagueness as a feature, right? It leaves a little wiggle room for negotiation. But computational systems absolutely despise vagueness. When you try to force an and/or through strict, true and false Boolean logic gates, that ambiguity instantly collapses. Deterministic code removes all adversarial interpretation. It either is or it isn't. No gray areas.
Think about a super dense traditional legal subclause full of clunky logical loops that ultimately end up in expensive litigation. Now compare that to a nested if-else block in code.
An if-else block dictates exactly what happens if a condition is met and exactly what happens if it fails. It takes massive, messy complexity and simplifies it into strict, collapsible gates.
Finally, Section 6, the future of law, the macro evolution of the profession. The practice of law is evolving exactly like the transportation industry. First, we had direct law, analog, bespoke, one-to-one lawyering. That's the horse and buggy. Then, mechanized law, current legal engineering, smart templates, document automation. This brings hyperspeed, like cars, but you still need a driver and guardrails. Finally, we are heading straight into automated law. These are the Waymos of the legal world. Autonomous, self-executing systems, where agreements run perfectly in the background based on the conditions we've coded. Building this automated Waymo future actually relies on a throwback, the 1980s Unix philosophy. The idea is to write programs that just do one thing really well and have them communicate via simple text streams. This creates modular, chained contract dependencies. If a prerequisite in the chain breaks, say a failed subscription payment, the downstream permission chain immediately stops. Using these text streams and clean JSON records also perfectly future-proofs your legal data for modern AI tools.
We've mapped the primitives, we've collapsed the ambiguities, and we've looked at this totally automated future. So here is the ultimate question for you. As legal text inevitably transforms into an active performance runtime, which path are you going to take? Will you become the engineer building the underlying infrastructure? Or will you be the modern lawyer, naturally operating with programming syntax because your deliverables have simply evolved into software? You have to choose. So how will you ensure you aren't left holding a static piece of paper?